Now let's solve product of array except self problem on LeetCode. In this problem, we're given an integer array nums, and we need to return any answer such that answer at I is equal to the product of all the elements of nums except nums at I. So in example 1, we have an array nums which contains 1, 2, 3, 4. What we're going to return at position I equals to 0, which is where the 1 currently resides, is 2 times 3 times 4. At position I equals to 1, where the 2 is, we have to return 1 times 3 times 4. So the first equation is equal to 24, the second is equal to 12. At position I equals to 2, which is the 3, we have to return 1 times 2 times 4, which is 8. And then at position I equals to 3, we need to return 1 times 2 times 3. The problem with this question is the constraint that our algorithm must run at O(n) time, and we cannot use the division operation. So initially, you may think to use nested for loops, but that would mean our algorithm would be running at O(n) squared, which is not permitted in this problem. So instead, what we're going to do is we're going to create 3 independent for loops, not nested, 3 independent for loops. And what we're going to do is for the first 2 for loops, we're going to create 2 empty arrays with the length equal to the length of the original nums array. One of them is going to be called left and the other is going to be called right. What we're going to do is at each index I, we're going to calculate the product of all the values to the left at index I, and we're going to assume at I equals to 0, so at the very first value, the values to the left are equal to 1. But for example, at I equals to 1, the value or the product of all the values to the left of 2 would be just 1. At I equals to 2, which is 3, it would be 2 times 1. And then at 4, it would be 3 times 2 times 1. And in our second for loop, which has an array called right, we're going to find the product of all the values to the right of the current index that we're on. And we're going to assume the product of the values to the right of the last index would be 1. The product of all the values to the right of 4 is 1. To the right of 3 would be just 4. To the right of 2 would be 3 times 4. And to the right of 1 would be 2 times 3 times 4. Now with these 2 arrays, what we're going to do is in our final for loop, at each index I, so in the beginning at I equals to 0, we're going to extract the value at index I from our left array and the value at index I of our right array, and we're going to multiply them together and store them in our final array, which will contain the output. So in other words, at I equals to 0, which is 1, we're going to multiply all the values to the left of 1, which we've stored in a array called left, by all the values to the right of 1, which are contained in a array called right. That way we don't take into account the 1 itself, and our algorithm runs at O(n) time. Let's go ahead and start solving now. So like I said, the first thing we're going to do is we're going to create our 3 empty arrays which have the same length as our original nums array. So let's go ahead and do that. First, we need an int n, which is equal to nums.length, because I want to input this as the size of our 3 arrays which we're going to create. Now we actually need to create the arrays. So int left equals new int that has a size of n. Int right is equal to new int, also size of n. And finally, int output equals new int. We can also call this product, doesn't really matter. So now we have to take the assumptions that all the values to the left of our first index are equal to 1, and all the values to the right of our last index are also equal to 1. So let's write that down. So in other words, the first value in our left array at index I equals to 0 is going to be equal to 1, and our last value in our right array, which is equal to n minus 1, since indices start at 0 in Java, is equal to 1. So now we actually have to start building arrays, so let's do that now. We're going to say for int I equals to 1, as long as I is less than n, or nums.length, or left.length, or right.length, or output.length. It doesn't really matter, so let's just say n, I++. We have to store in our left array at index I, starting at 1, since index 0 is already equal to 1. What are we going to store in left at index I? So at 2, which is I equals to 1, we need to store the product of all the values to the left of 2, 2 not included. That would be just 1. At index I equals to 2, which would be 3, we need to do 2 times 1. But how do we do that without using nested for loops to retrieve multiple values? So for example at 4, how would we do 3 times 2 times 1 without using nested for loops to access multiple elements? What we're going to do is we're going to access our left array at I minus 1 and multiply it by the value at nums at I minus 1. So let's take a look. Left at index 1 is going to be equal to left at index 1 minus 1, which is 0, which is equal to 1, times nums at I minus 1, which would be also nums at 0, which is 1. 1 times 1, that's 1. And so our left array is going to look like this. And that makes sense since we said all the values to the left of the first index, so I equals to 0 is equal to 1. And the product of all the values to the left of index I equals to 2 is just 1. Let's keep going with this code. So the value at left pointing at position 2 would have to be 2 times 1. So this is going to be equal to left at I minus 1, which is left at 2 minus 1, which is 1, which is equal to 1, as we can see in our array. And we need to multiply it by nums at I minus 1, which is 2. So 2 times 1, that's 2. And so that makes sense since all the product of the values to the left of 3 are 2 times 1. And then finally, the value at index 3 would be left of 3 minus 1, which is 2, times nums at I minus 1, which is 3. So 2 times 3, that's 6. And the product of the values to the left of 4 is 3 times 2 times 1, which is 6. So we're going to apply the same principle basically for our right array. But instead of starting at the beginning of our array, so at I equals to 1, we're actually going to start at I equals to n minus 2, which in this case is 3. First of all, that's because we already took into account right at n minus 1, so at the last index, which is 4. So we have to process the element before 4, which is 3. And the second reason is because if we start at I equals to 1, which is 2, we don't know what the product of 3 times 4 is yet since it's not stored in our array. So once we get to 2, because we started at the end of our list, we're going to have a record for 3 times 4, which we can use to solve the product of 1, for example, and so on. So for int I equals to n minus 2, as long as I is greater than or equal to 0, I minus minus, again, right at I is going to be equal to right at I plus 1 times nums at I plus 1. So it's kind of the opposite of our left array because we're starting at the end of our list and we need the values to the right, not to the left. So this becomes I plus 1. So now with our left and right arrays built, we can now do the final array where we need to return output. So in a for loop, for int I equals to 0, we need to iterate through the elements of our arrays, which are all the same length, as long as I is less than n, I plus plus. Output at I is going to be equal to left at position I times right at position I. So left at position I times right at position I. So as you can see, when we multiply the values at index I in both array, 1 times 24, that's 24, we're gonna get the correct output. So 1 times 24 is 24, 1 times 12 is 12, 2 times 4 is 8, and then 6 times 1 is 6. So all we have to do now is return output. Let's submit our code. And there we go. So that was the product of array except self problem on LeetCode. I hope you found that video helpful, and thanks for watching.